Hello and welcome to G Fun Facts Online, the show that uncovers the amazing science in the world all around us. Take a look at your desk right now. What do you see? A pen, your computer, maybe a cup of coffee. What about a simple piece of paper? It seems ordinary, maybe even a little outdated in our digital world. But what if I told you that this humble sheet could hold the key to powering the next generation of our electronics? Today, we're peeling back the layers on an incredible innovation, the paper battery. We'll explore how you can turn paper into a power source, why it could be a game changer for our planet, and where you might see these paper-thin powerhouses popping up in the very near future. Stick around, because this is one story you won't want to fold away. So how on earth do you get electricity from paper? It sounds like something out of a science fiction movie, but the principle is actually grounded in the same science as the battery in your phone. Every conventional battery has three key parts: a positive end called the cathode, a negative end called the anode, and a substance in between called the electrolyte, which lets charged particles, or ions, move from one end to the other. This movement is what creates an electrical current. Paper batteries follow this exact same blueprint, but with some wonderfully clever twists. It all starts with a sheet of cellulose-based paper. You know, the stuff made from wood pulp. The magic of paper is its structure. If you zoomed in, you'd see it's a mesh of tiny fibers, making it incredibly porous. This porous nature is a huge advantage, because it acts like a sponge, allowing the electrolyte and its ions to move around freely, which is essential for a battery to work efficiently. But paper itself doesn't conduct electricity. To fix that, scientists get creative. They coat the paper with special, high-tech inks. These aren't your everyday fountain pen inks. They're packed with nanomaterials. For the cathode, the positive side, they often use an ink containing carbon nanotubes, microscopic cylinders of carbon that are incredibly conductive. For the anode, the negative side, they might use a thin layer of lithium metal or another suitable material. These tiny nanostructures create a massive surface area, which is like building a multi-lane superhighway for electricity, boosting the battery's performance. Now for the electrolyte. This is the liquid that kicks everything into gear. In paper batteries, this can be a special gel or an ionic liquid. In some of the most fascinating designs, the electrolyte is activated with just a few drops of water. The water dissolves salts that are already embedded in the paper, releasing those crucial ions and starting the electrochemical reaction that generates power. Some prototypes can even be powered by bodily fluids, like sweat or urine, which sounds a bit strange, but opens up incredible possibilities for medical devices. And here's the most elegant part. The paper itself does double duty. Not only is it the foundation, but it also acts as a natural separator, a barrier that keeps the anode and cathode from touching. If they touched, you'd get a short circuit, and the battery would be useless. So the paper substrate, the nanoparticle ink electrodes, and the water-activated electrolyte all come together. When you connect a device, electrons flow from the anode through your device to the cathode, powering it up. Meanwhile, ions travel through the electrolyte inside the paper to complete the circuit. In some versions, this whole process is even reversible, meaning you can recharge them. It's a simple, elegant, and powerful reinvention of a technology we use every single day. Now, a clever piece of tech is one thing, but what makes paper batteries truly exciting is their potential to solve one of the biggest environmental headaches of our time: electronic waste. Think about all the batteries you've used and thrown away in your lifetime, from the tiny ones in your watch to the larger ones in your old gadgets. Traditional batteries are packed with toxic heavy metals, like lead, mercury, and cadmium. When they end up in landfills, these toxins can leak into the soil and our water systems, causing serious environmental damage. It's a massive, persistent problem. Paper batteries offer a beautifully simple solution. They are designed to disappear. Many of the current designs are biodegradable and even compostable. Scientists at Nanyang Technological University in Singapore, for example, have created paper-thin batteries made with zinc. When you're done with them, you can literally bury them in the dirt, and within about a month, they completely break down. The materials they release, like zinc or manganese, are left behind in forms similar to natural minerals already found in the soil. It's the ultimate sustainable life cycle. By making batteries out of paper and other non-toxic materials, we could drastically reduce the mountain of e-waste we generate each year. Imagine a world where the power source for a disposable medical device or a smart shipping label simply returns to the earth after its job is done. This isn't just about making electronics more convenient, it's about making them fundamentally kinder to our planet. The eco-friendly nature of paper batteries is a huge selling point, but their physical properties are what truly unlock a world of futuristic applications. They are thin, lightweight, and most importantly, flexible. This opens the door to technology that was once the stuff of spy movies. Let's start with wearable technology. Forget clunky fitness trackers. Imagine smart clothing with a battery woven directly into the fabric, monitoring your heart rate and body temperature throughout the day. Or electronic skin, a thin patch that sticks to you like a temporary tattoo, powered by a battery that flexes and moves with your body. In the medical field, the possibilities are even more profound. Biodegradable batteries are perfect for temporary medical implants. Think of a device that helps a bone heal, and then, once its job is done, it and its battery simply and harmlessly dissolve inside the body, eliminating the need for a second surgery to remove it. They're also ideal for disposable diagnostic kits, bringing low-cost medical testing to remote areas. Then there's smart packaging. A paper battery could be integrated into a shipping label, powering a sensor that tracks a package's location, temperature, and whether it's been tampered with, all in real time. And what about all those small, single-use electronics? The musical greeting card, the flashing party favor, or the disposable environmental sensor dropped in a forest to monitor for fires. Using a biodegradable paper battery means these items won't leave a toxic legacy behind. We're already seeing proof that this isn't just theory. In one study, a tiny paper battery, just 4 centimeters square, was able to power a small electric fan for 45 minutes. And here's the amazing part. It kept working even when researchers bent it, twisted it, and even cut off a piece of it. This kind of resilience is crucial as our gadgets evolve. With the rise of foldable smartphones and roll-up displays, we need power sources that can bend and flex right along with them. Paper batteries are perfectly suited for this flexible future. As promising as all this sounds, we probably won't be powering our laptops with paper batteries tomorrow. Like any emerging technology, there are still some significant hurdles to overcome. The first major challenge is power output. Right now, most paper batteries just can't store or deliver as much energy as a traditional lithium-ion battery of the same size. They're great for low-power applications like a small sensor or an LED light, but powering a high-performance smartphone for a full day is still out of reach. Another issue is cost. The special nanomaterials used in the conductive inks, like those carbon nanotubes we talked about, can be expensive to produce in large quantities. For paper batteries to become a mainstream product, manufacturers need to find a way to make them affordable. Finally, there's durability. While their flexibility is a strength, they are still, at their core, made of paper. The cellulose substrate can be prone to tearing or degrading over time, especially in rechargeable versions that go through many cycles of use. But the good news is that scientists and engineers around the world are actively working on solving these very problems. They're experimenting with different materials to boost performance and cut costs. For instance, some researchers are looking at using paper made from seaweed, which is not only highly sustainable, but also has properties that could make for a more efficient battery. Others are perfecting water-activated paper batteries that are completely non-toxic and can produce a stable voltage comparable to a standard AA battery. The road ahead involves continuous innovation, refining the materials, and scaling up production. So, from a simple sheet of cellulose to a flexible, biodegradable power source, the journey of the paper battery is a remarkable testament to human ingenuity. It shows us that solutions to some of our biggest technological and environmental challenges might be found in the most unexpected and ordinary materials. While they may not replace all batteries overnight, paper batteries are carving out a crucial niche in the world of electronics. They promise a future of smarter medical devices, more intelligent packaging, and truly wearable technology that's in sync with both our bodies and our planet. The power of paper is poised to help us build a world that is not only more technologically advanced, but also more sustainable. So the next time you pick up a piece of paper, take a moment. You might just be holding a blueprint for the future of energy. Thanks for tuning in to G Fun Facts Online. Join us next time as we explore another amazing piece of our world.